Hello and welcome. This is the Freedom Research Podcast, and my name is Hannes Sarv. My guest today is from Canada, Ross McKitrick, a professor of economics at the University of Guelph in Ontario, where he specializes in environment, energy, and climate policy and has published widely on economics of pollution, climate change and public policy. His background is in statistics, and this has led him to collaborative work across a wide range of topics in the physical sciences, including paleoclimate reconstruction, malaria transmission, surface temperature measurement, and climate model evaluation. So, Professor, it is an honor to meet you here, and thank you for taking this time and giving us this interview.
My pleasure.
So, Professor, I would actually like to start by asking about a bit of background about you as a scientist, your development, because you're an economist and you developed a long time ago basically an interest into environmental policies and climate change. You have been engaged with that debate for decades already. So how and why you developed such an interest in this topic of climate change and global warming?
Well, I guess I'm going to date myself by saying that I did my undergraduate work in economics in the 1980s, starting in 1984. And when I finished and I was thinking about graduate school, environmental issues were just then starting to really come into the news. And as someone training in economics, I thought, well, economics probably has a lot to contribute to this, and I'd like to see what we can do to help. And also I was concerned in what I was hearing, especially around things like the ozone layer and climate change, but also waste management, all kinds of environmental issues that people seem to throw economics aside. There was a thinking, especially back then, that, well, economics is the problem, so we have to just ignore economics and focus on regulations and government-led solutions. And I thought, that's probably not going to end up being a very effective way to proceed. So I went to the University of British Columbia in 1989, started my master's and PhD work there, and I focused on environmental economics, which back then wasn't even much of a field. There weren't really people working in it, but there was a lot of interest in it. And when it came time to pick a topic for my dissertation, I decided to focus on climate change because Canada was beginning to think about whether a carbon tax would make sense. And the economics was interesting, and the data was there to work on it. So that's what I did. I ended up doing a PhD in economics with a focus on climate policy and carbon taxes in particular. And so in the mid-1990s, around 96, I started here at the University of Guelph, which is about an hour west of Toronto for your watchers and listeners. And so that was in the lead up to the Kyoto Protocol. And there were a lot of meetings going on in Canada and elsewhere, people just starting to try to figure out the whole climate issue. So a typical meeting would be they'd want an economist to come and talk about the policy issues, and then some scientists to talk about the science issues. And there weren't many people working on the topic, so I would often get invited to these kinds of meetings, and I'd see the standard science presentation. Didn't really have any opinion on it one way or the other. I just took it all in, and then a couple of years later, after being at another one of these meetings, for the first time, I saw someone present the weather satellite data. And it was, to me, quite an unusual thing, because I'd seen lots of presentations of the surface thermometer data and the description of the global warming problem. And then somebody said there's also this satellite data that's measuring the layers of the atmosphere where all this is supposed to be happening, and doesn't show any warming, which is kind of unusual. But then it was waved away, not considered an important topic. And I thought, wait a second, that's a kind of an important point. That, we should understand this before we go rushing into some of these expensive policies. We need to ask how solid the science here is. And if they're not telling us that there's this other data set that's contradicting the surface measurements, what else are they not telling us?
So when was that? When was that?
This would be around 2000, around the turn of the century. And so by this point, I was teaching on climate change and climate economics, and I would always just use kind of standard Scientific American kind of summary articles that give the standard story and some of the warnings. And so I began to look at some of the science papers, some of things from the World Meteorological Organization, and the IPCC by that point was up and running. And immediately was struck by the fact that the statistical analysis wasn't very impressive, that they were doing really rudimentary analyses, and it was clear that they didn't have as much training in statistics as an economist would. So in doing my PhD in economics, I was not a specialist in econometrics, but I still had altogether 10 courses in statistics and multivariate econometric methods. And that's pretty standard in economics. So I would begin getting these data sets and just doing some work with them. And the questions that I would put to climate scientists made it clear that they really didn't have the background to be doing the kind of statistical work that they were talking about. So fast forward a couple of years, I was very involved in the public discussion around the Kyoto Protocol. I was still, of course, doing a lot of work on the economic side of it. And then out of the blue, I got contacted by this guy named Stephen McIntyre, who lived in Toronto, who was a mathematician by training, who was trying to replicate the hockey stick graph. And so this was 2003. And Steve sent me the notes that he was doing, and I could see that he'd actually done some really important work, and but he needed help getting it written up for publication. So he and I joined forces in 2003 and started working on trying to figure out where the hockey stick came from, and then we of course found errors in that and exposed a lot of problems.
I think we should actually a bit talk about that, because Michael Mann's hockey stick is something that is still used as a fact or a basis for common people, not scientists, simple people like myself, for example, that you see, this is what carbon dioxide, or this is what anthropogenic global warming looks like. So in the simplest way possible, if you can, explain us, what's the problem there?
Well, what attracted Steve's interest was he was able to get access to the original data that went into the hockey stick graph. And these are long paleoclimate series, mostly tree rings, things like that. And just graphing them up, they didn't look like hockey sticks. And most of the data series just had no trend at all. And a lot of them even go down in the 20th century. So then he thought, all right, it was something in the statistics that introduced the hockey stick. And so then it's a matter of looking at what Mann's article said they did with their data, and then trying to replicate the steps. And this is where he was really, I think, the first person to independently try to figure out all those steps and write computer programs to replicate them. And it was in the course of the steps that they followed. They did some non-standard transformations of the data that mine the data record for any hockey stick shape that's there. And as it turns out, there's a small number of data series in their record. Out of 400 data series, there's a small number, about 20, that look like hockey sticks. What it does is it pulls them out, puts all the weight on those series, and throws everything else out. And then that'd be a bad enough technique to begin with. But then the additional problem is those 20 series, the bristlecone pines, were known in the field not to be good temperature proxies. They're whatever they're recording, the growth in the 20th century, the original authors had said, well, there's no warming trend in this area, so they're not recording temperature. it might be CO2 fertilization or disturbance to the land or something like that, but don't use them as temperature proxies. So we put a couple of papers into the literature showing that this technique that they had used creates an artificial hockey stick shape that's not really there in the data, and that these paleoclimate reconstructions, and there's the hockey stick, but there have been more since then. There have been a bunch of them that have appeared over time, conveniently all looking enough like a hockey stick that it always shows the present day warmer than the medieval period. But the thing about them is they all have massive uncertainties in them, and they draw tiny little error bars on them to make it look like they've done some kind of statistical analysis, and you can trust the results. But the uncertainties are extremely large. They're largely uninformative about the ancient climate. The exception is if you're looking at one location. So if you have proxy records for a single location, and you have temperature records, so you can calibrate in the overlap period and show that whatever proxy you're using, it really does pick up the year-to-year variations. Then at that location, the tree ring record or whatever the proxy record you're using, those can be quite informative about the past climate. But when you get into these large-scale northern hemisphere, southern hemisphere, or global reconstructions, then there's so much extrapolation and so much uncertainty. And people have shown, and again, it's not climate scientists, it's outside statisticians who have taken the data and shown, sorry, but you can get any climate history you want from this data, and you have no way statistically to say that a hockey stick shape is the preferred outcome versus some completely different shape.
Okay, this is really interesting. That well, when you talk about it and explain it, it kind of any person could get it who pays attention. But there was this court case not so long ago, and how to tell it to a jury. So, what do you think? What went wrong there?
Mm-hmm. Well, I think we did a good job of explaining it to the jury. I think the defense attorneys that were involved really understood the material and did the best they could. But a court is a terrible place to debate a climate science issue.
Yeah.
Excuse me. And in that case, the outcome was, I don't think in the end the outcome was the jury saying, yeah, the statistical analysis behind the climate, behind the hockey stick is perfectly valid and we accept it. It was much more a political decision in a town like Washington, D.C., which leans very heavily Democrat. The plaintiff's lawyer, Michael Mann's lawyer, made it clear that the defendants were just evil right-wing Republican types, probably Trump supporters, and that's all the jury heard in the end.
Yeah. And this is a sad truth about maybe the whole issue of climate debate today, that it has become so political. And I don't know how you feel, but as I have talked to other scientists as yourself, the frustration does not come from the fact that some other scientists or some other people are in fact looking at the data in a different way or drawing different conclusions based on the data, but the frustration comes that you cannot debate without name calling, labeling, etc., etc. How do you feel about that? You probably have had to encounter such things the whole time you have discussed this climate science.
Yeah, it's the political angle is definitely there, but I am an economist by training, and most issues in economics, there's a political overlay to it. So back in the 1980s, Canada went through a big debate over whether to have a free trade agreement with the United States. And so there were economists on both sides of that issue, and most economists were in support of the free trade agreement, but politically, it was the Conservative Party was in favor and the Liberal Party was opposed. So you had the political mudslinging, and you had some academic debate going on, and the two clashed and collided that way. That ended up in an election. The issue was decided, and people went on from there. There are a lot of issues. Another one right now, totally unrelated to climate, though, is the question, is it better for children to grow up in a two-parent family, or is there an economic disadvantage to single parenthood? And so that's a case where economists have looked at it and have said, no, the data here is quite clear that two-parent families is how you want kids to be growing up. And yet single-parent families, the numbers are exploding all over the United States. This is a rising trend. So there you've got another case where you're going to have political commentators breaking down on partisan grounds. You'll have conservatives will say, well, of course you want two-parent families, you know, traditional family structures. And then on the left, you'll have them saying, no, we don't believe in traditional families are necessary. So you get the political debate going, and then academics are making contributions in it and getting caught up in the political debate in ways that they either might be comfortable with or not comfortable with. But I guess my point is, as an economist, this is nothing new. So on climate policy, same thing. We've got on the left, you have people that even if the climate issue had never come along, they'd be happy to be chanting revolutionary slogans and wanting to dismantle industrial capitalism. Climate change is just a convenient horse to ride in that debate. But other people on the left actually seem to believe in the energy transition, and we should have renewable energy and this sort of stuff. People on the right prefer market systems. They look at the history of the Western economy and say, no, look, fossil fuels are a major contributor to our standard of living. We got to keep using them, make it workable to keep using them. So that political debate is going on, and then economists are weighing in on the climate policy issues in the middle of that. It's kind of standard in a day's work for us that you try to inject some academic rigor into what is ultimately going to be a political debate. Now, on the scientist side, I could see that for a lot of them, it's an unusual thing. Maybe they didn't feel like they didn't sign up for their scientific work to be caught in the middle of a political debate. But at the same time, I think I don't really believe that. I think a lot of scientists at universities now, it's so out of balance. The political makeup at the typical Western university is so overwhelmingly on the left now that I think a lot of them do secretly think, I would like it if the papers that I publish are beneficial to politicians on the left, and I resent it if the work I publish is beneficial to politicians on the right. So I might even shape my publication and research work with that in mind. I think that's there just because of over the past 30 years or so, the distorted hiring practices at universities that have led to this current completely out of balance situation.
But anyway, like I was saying about the universities are leaning to the left, and they have those policies place and so on. So I would say that in this climate debate, if we look at it as a political thing, then the left, which you described, is winning, because we constantly hear from politicians, from, I don't know, United Nations Secretary General says to us that there's a big climate catastrophe that we are living in, and we are living in a global boiling era, and so on and so on. So where does this come from? And also, is there anything to it? Because, of course, humans change nature and the environment all the time. So is there anything to it? Should we be worried? What do you think?
It's important to begin at the secure level, the basic level, which is that carbon dioxide, which is a byproduct of using fossil fuels, you have to release CO2 when you burn fossil fuels. We have no practical way of using fossil fuels without releasing CO2. So it is going into the atmosphere, and carbon dioxide is a greenhouse gas. So it does have this infrared absorbing property. So that on its own, we expect there to be some warming of the atmosphere from adding CO2 to it. And that's been known for 150 years. Then the question is it going to be a lot of warming or a little bit? And how will that affect our weather systems and life on Earth? And that's where all the uncertainties are. And most of those uncertainties are still quite large. There's been very little progress in answering that question. Is it a large effect or a small effect? There's very good evidence for a small effect. I think it's actually stronger than evidence in the other way. But there are some climate models that can give you a big effect. And you'd have to have certain assumptions in place. But I think it's a small effect. And then is it a bad effect or a good effect? For a long time, economists who have looked at this and looked at how society has responded to weather changes in the past have come out and said, most places in the world, there'll be a slight benefit if they're, especially in a colder country, bad if you're in the tropics, but also just because of the climate system, the warming is smaller in the tropics than in the northern and southern regions. So it hasn't been a huge issue in the minds of economists, although the last 5 or 10 years, there are younger economists now that are coming up with studies that say, no, this is actually, it could be a really big problem. But even those ones, you don't come to the conclusion that we should stop using fossil fuels. It's more like, well, we may have to adjust to some big changes, and we may have to compensate the losers more than we thought we otherwise would. But it's very difficult to do an economic analysis that would come to a conclusion like we need to go to net zero by 2050 or anything like that. Like, I know that's the common proposal at the political level, but in economic models, it's more, no, we just keep using the fossil fuels, but we prepare for the changes, including some negative changes that will happen. So as far as should people be worried, most of what you hear, at least most of what I hear in the media, is ridiculous. It's the filter that's there is the normal, sensible, scientifically sound work never makes the papers. What makes the papers is the far out, outrageous, speculative stuff about the worst case scenario. So don't go by what you're seeing in the papers. Even in the IPCC reports, it's the same thing. There's a lot of material in the IPCC reports that if you take the time to read it, especially around extreme weather, for instance, for all the years they've been putting those out, every time they get to talking about extreme weather, they pretty much back off and say, well, we can't really see any trends in the big forms of extreme weather. Heat waves are some evidence that they've gotten worse. Although not in the United States, the 1930s was far worse than anything we've had since. But the major forms of extreme weather, they're not really trends, and we don't really expect there to be as a result of CO2 emissions. So, so that's not so much of an issue. And then one of the issues that rarely gets discussed about the extra CO2, it's not like other types of air pollution that are actually toxic. It's bad to have ground level ozone. It's bad to have carbon monoxide, and it's bad to have a lot of sulfur in the air. But at the same time, we've fixed most of that. Like air quality is really good now in comparison to the 1950s. But with carbon dioxide, it's actually good for plants. It's the global greening that's going on is spectacular with all this extra CO2 in the air, and it's improved agricultural productivity, and it's turning deserts into green spaces. And so this aspect of it, again, doesn't make the headlines, doesn't get discussed in the news, but it's a very real phenomenon, is a bonus from having extra CO2 in the air. One thing I will say, people can legitimately say, yeah, I worry about this, is the sheer volume of CO2 that's going into the air and changing the atmospheric concentration on a short time scale. I don't think 20 years ago we expected China and India to develop and industrialize as fast as they're doing. And they're clearly riding the coal train to do that. And no one in the West is going to stop them just by wagging their finger and saying you shouldn't. So that is an aspect of it where I think people can legitimately say, I'd rather it wasn't happening as fast as it is. But at the same time, wealth and income around the world have gone up a lot, and in the process, they've made people much less vulnerable to environmental catastrophes and problems of all kinds. So as the CO2 level is going up in the air, so is the incomes or the resources to deal with whatever challenges we encounter in the natural world, and weather vulnerability and things like that. So there's another side even to that part.
Yeah, I mean, if we think about China and India, and then think about our aims in the European Union or in Canada or even in the United States, that we have to get to net zero. So they're not going to get to net zero. And as far as I understand, then if we combine the North America and the EU, then we get something like 25% of anthropogenic carbon dioxide emissions. So if we do that, if we really do that, do everything that we promise, does it make any difference if China and India are building coal plants like 2 per week or something like that?
The short answer is no, it doesn't. Back at the time of the Kyoto Protocol, there was a study done by an American scientist, Tom Wigley, who asked a simple question: what would happen to the global CO2 concentration in the atmosphere over the next 100 years if every country that signed up for Kyoto did everything they're promising to do? And so the graph in that paper, I show it to my students, it's quite surprising. You've got the base case, so CO2 goes up in the air because of all the emissions. And then the next line is what the CO2 profile looks like if everyone follows Kyoto Protocol. And it goes up almost exactly the same. You can barely make out the gap between the two lines. And the reason is, first of all, something like Kyoto Protocol is just asking countries to cut their emissions by a small fraction currently. Now, it's capped, so it can't grow after that, but it still leaves a lot of emissions. And then you have most of the world not affected by it. And then you've also got the carbon cycle, which is very large in comparison to our own emissions. So what you ultimately end up with is the same outcome. The emission or the CO2 concentration we would have reached in the year 2100, we still get there, but maybe in 2105 instead. Now, with the Paris Climate Treaty, Bjorn Lomborg did a similar exercise and published a graph, and it's the same story. If everyone signed up to Paris, does everything that they promised, whatever climate you're going to get to in the year 2100, you get there a few years later. It's slowing the process down a little bit. And that's assuming that the emission reductions in a place like Europe are absolute emission reductions at the global level. But of course, what really happens is the emitting activity that you shut down in Europe, it doesn't just disappear off the face of the earth. A lot of it moves to other places that aren't party to the treaty. So in the case of the Kyoto emission reductions, there is evidence that they were fully offset by increased economic activity outside of the Kyoto countries. So in that case, there's no effect whatsoever. But even if you assume that displacement or that leakage effect, as we call it, even if it didn't happen, a best case scenario is still very little effect from these kinds of treaties. Going back to a point you made earlier about the discussion is dominated by the alarmist side, by the left. They seem to control the whole discussion, even up to the level of the Secretary General of the United Nations, who says outrageous things like it's the era of global boiling. There's a pattern that forms here, and we're going to see it play out over and over, that because of the common interests of the media and some of the corporate interests involved and the politicians and so on, this alarmist message gets amplified. It's not challenged in public. And the result is politicians embrace these targets, these policy targets, net zero or 30% reduction by the end of the decade, things like that. And the public loves it. The sales job for the public is very effective, and it happens here in Canada too. But they're always told this won't cost anything. This will actually be good for the economy. So the public hears there's a big problem, we have to act, and the solution will make us better off. So of course they sign up for it. They love it. They'll elect people on that basis. But then the policies actually get put in place. And even the smallest version of those policies hits people hard in the pocketbooks in the way that they weren't warned about. They were not prepared for the economic hit, and they never consented to it. And so that's when you get the reaction in the opposite direction. And we've seen that in Canada. Here in my own province of Ontario, the provincial government brought in, they phased out coal plants, brought in wind and solar power. Electricity prices went through the roof, and the government was not just thrown out, but they were wiped out as a political party. The public was so angry about it. And at the federal level, similar things are happening now. We have a carbon tax in Canada, which is just, it's fairly high, but it's not nearly as high as the government plans to make it. And they were elected with this promise they're going to bring in this carbon tax. But again, they sold it to the public as, don't worry, it won't cost you anything. You'll be better off and it'll help the environment. Well, now it's really showing up in people's home heating bills and the cost of gasoline and things like that. And for that reason, for other reasons as well, but a large part of it is the carbon tax. The current government is deeply unpopular and will almost certainly be wiped out in the next election. Mm-hmm. So I think you can hold this as a rule that the public loves promises of aggressive climate policy, but when politicians try to implement it, they will get voted out of office. And until the politicians realize those two rules go together, they're going to keep making the mistake. So yes, people on the right tend to argue, let's not do these climate policies because they're far too expensive. They do more harm than good. They won't fix anything, and it's a bad idea. Nobody listens to that during the debate stage. But
yes,
down the road, when prices start going up, suddenly people realize that's what you meant. Okay, now we're listening.
Another myth or another thing that they are telling us, and you pointed it out as well, is that moving or phasing out fossil fuels and moving to renewables will make our economies grow. So as far as I can understand, our economies are actually quite dependent on our energy systems, and maybe you can correct me, but as far as I can understand, then there will be no growth if we really meant it, if we went to renewables. You just cannot, because this is, as an energy source right now, this is unreliable.
Yeah, if the slogans were true, if wind and solar really were the cheapest forms of energy, we would have been using them a long time ago, and you wouldn't need government mandates to force utilities to put them into place. Our utilities, the electricity system, it's been their job for over a century to understand all the ways you can generate electricity and to pursue ideally the cheapest and most reliable systems for each nation in the particular context. So in Ontario, we have hydroelectricity because we've got rivers, and we have nuclear plants because we have CANDU reactors here in Canada, and we have some fossil fuel powered. In other parts of Canada, it's a different mix because of the different geography and different resources. But historically, the goal has always been reliable electricity at the lowest possible cost. And all along the way, the engineers in that system have looked at wind and solar as possible options and never showed any interest in them. They are expensive to build, and what you end up with are intermittent, unreliable electricity sources. So when people hear someone say wind is now the cheapest form of power, you need to understand there's a catch. It's the cheapest form of power if you ignore the intermittent aspect, that when the wind isn't blowing, you don't get any power. Even if you need the electricity, it's not going to be there. And I think a good analogy is if you want to build a railroad across your country and you have two companies and one of them says, my bid is a lot cheaper than the other guys. Look, I'll do it for half the cost. The only problem is every 10 miles or so, there's a 3-mile gap in the track. So as long as you can live with that, then my bid is cheaper. Well, obviously, the fact that it's cheaper doesn't help because it's now useless as a railroad. And electricity systems that are running on wind are useless for the same purpose. You can't have an electricity system that when the wind dies down, there's no electricity. So then the proper comparison would be, how much would it cost to build a wind-based electricity system that provides guaranteed levels of power 24 hours a day, 7 days a week? Okay, now you've got to have storage. You have to have some way of storing the excess electricity when the wind is blowing and you don't need it. And whether it's trying to build a lake in the sky and pump water uphill and fill a reservoir, or battery systems, which no one can even conceive of how you'd have batteries large enough to run an entire country for anything more than 30 seconds or so. The storage systems aren't there, but anything that people talk about are so incredibly expensive that suddenly the cost comparison goes back to where it always was, which is fossil fuel-based systems are inexpensive and 100% reliable. Nuclear is very expensive to build, but once it's there, it's very inexpensive to run and lasts a long, long time. Hydro, if you've got it, that's another good source. Again, there's extreme cases. If the reservoirs really dry up, you might need a backup. But yeah, those are the systems that we've used because they're the ones that work. And when you factor in the reliability, they're also the least expensive overall. Wind and solar, they will never be competitive because of the intermittency. And so at this point, people have kind of clued in a place like Ontario where, okay, if we start building all these windmills, we also need to build a lot of natural gas power plants to run in the background and provide the backup. So you have to add that cost in. And then it's silly to build two generating systems to run at the same time. That's the inefficiency.
Yeah, and I always wonder economically. I mean, if you build these systems and they tell you that it is cheap, for example, then actually the costs of building them are they calculate in the money that comes from the taxpayer. I mean, it's always subsidized.
Yeah.
So
yes.
Well, if you look at it and know it, you can see that of course it's not cheap, but everything that it costs, and the costs are on the whole system. I mean, taxpayers us are paying for it, and at the same time, the effort that is made to build those things. I mean, the materials, the elements from the ground, excavation, and you think about it, then it's also not good for the environment. That's my logic, at least. So, what are we doing here?
Yeah, the whole hype around solar energy and wind energy being great economic opportunities. And sometimes you'll see a chart, consultants who flog this kind of stuff, who like to sell it to gullible politicians. They'll show a chart of, look how quickly the solar energy industry is growing. But the chart comes from a place like California, where the government announced enormous subsidies for people to buy and install solar panels on their houses. So sure, a lot of suppliers appear to sell people this stuff, but it's all subsidized. It's not like smartphones or something where a market appeared because of technology where it's genuinely profitable and it has an organic economic aspect to it. It's all artificial. It's all driven by subsidies. And when the subsidies end, the industry disappears. In Ontario, again, to use the local example, in the middle of the last decade, around 2006, 2007, the province got interested in wind turbines, and then after the financial crisis of 2008, they decided this would be an economic recovery scheme. We will start mandating wind energy and offering big subsidies to wind farms. And what they sold to the public was Ontario is now going to be a world leader in the manufacture of wind turbines, and everybody's going to be lining up to buy wind turbines from us. So this will be a great economic benefit. It's always the case, there are no exceptions historically, that if an industry appears only in response to government subsidies, if it's not something that the private sector was interested in doing without the subsidies, it's not a source of economic growth. It is a net drain on the economy. And that was the case here as well. No, we didn't have any comparative advantage in building wind turbines. We don't have a wind turbine industry in Ontario. We ended up importing all the parts. The turbines went up and the government changed and the subsidies disappeared. The whole industry disappeared. It will happen everywhere people try this, that if it's a subsidy-driven industry, it's gone as soon as the subsidies are gone. And as long as the subsidies are in place, it's a drain on your society. It is destroying your national wealth, not building it.
Yeah. So let me follow up on, you mentioned also the IPCC reports, which I know you have also, have a lot of knowledge, but as an average person, I haven't read them. There are thousands of pages long. But as I understand, reading some of the articles about them, they actually don't show you that you have to be, they don't actually, there are no apocalyptic messages in those models. There are several models there. Some show more warming, some show less warming, and now I think there's a debate that the most heating model should be revised and brought down. But is it correct that they do not actually show what is being basically propagated, that we have a catastrophe?
Well, the short answer is no. They don't use language like climate crisis or climate catastrophe or climate emergency or anything like that. That language is not in the IPCC reports. There's a bunch of different groups within the IPCC. It's a very large thing now. So there's Working Group 1, which every 6 years or so prepares a scientific review. And then there's Working Group 2, which is more focused on the impacts and the economic analysis. And then there's Working Group 3, which is a bit hard to pin down what it's about, but it's looks more at things like renewable energy options and some of the long-term policy options. Working Groups 2 and 3 over the years have become weaker and weaker. In the 1990s and 20 years ago, Working Group 2 still had a lot of economists involved in it. And even in the fifth assessment report, which is 2013, Working Group 2, in Chapter 10, it was their comprehensive review of the impacts of climate change on economies around the world. And there, the conclusions were really blunt. And people don't realize this, but they came out and said, over the next 100 years, the impacts of climate change are going to be pretty small in comparison to everything else that changes. That's not exactly word for word, but if you look up Chapter 10, Working Group 2, Fifth Assessment Report, right at the beginning. This is how they start the chapter. Impacts of climate change are going to be small compared to, and then they list everything else: technology, population change, market changes, all the rest of it. In comparison to all that, climate change effects are going to be pretty small. And so that was just 10 years ago that the IPCC was saying that. Working Group 1, I've been a reviewer for Working Group 1 for the past 3 assessment reports, and it can be frustrating. Again, there's attrition. A lot of good people no longer bother contributing to it, and the reason has to do with the review process. So there's a bureau in Geneva that gets to pick who are going to be the lead authors, and you can tell by looking at the list of lead authors what's the message they want, because these are going to be authors whose work is associated with a certain side of the story. So the chapter draft is going to be tilted in their direction. And then it goes out for review. There's no assignment of reviewers. So any particular section of the report, it may not actually have been reviewed by anyone. There's no requirement to review any particular part of it. But even the parts that I've reviewed, the thing is, you put in review comments, a lot of work, you have to read a lot of stuff, you have to put in all your written comments. They're free to ignore your comments. So this is very different from academic journals. If the authors don't agree with you, they can just say, I disagree, and ignore your comment. And so at a certain point, a lot of people have just stopped bothering reviewing them because it can be a total waste of effort. Sometimes they'll change the text, but it's often, they might make a grudging change to take note of a comment, but again, they don't have to. It's the lead authors who get to decide what goes in. So even still, Working Group 1 has stayed at least connected to the underlying data and the underlying scientific literature. In Working Groups 2 and 3 in the 6th assessment report, now with very few economists connected to it, and then they get into some of these very speculative policy topics. In those reports now, they've begun to lean a little bit towards using, I think they use the word urgent in one of their chapter headings. They call it this urgent moment. And again, as a reviewer, I saw that and I said, look, get that out of there. That doesn't belong in a report like this. That's political language, but they kept it in. And but even still, when the report came out and the Secretary General said, how did he put it? UN Secretary General said, this report is like a 5-alarm fire, or it's telling us that we have a climate crisis. And people might think, oh, that's terrible. The scientists are all saying we have a crisis.
Exactly.
And, but as you pointed out, no, they don't. That's not in the report. He made that up. There's no language anywhere close to that in the report. The language in the report is still tilted, I think, towards the alarmist side, but they're still sticking to what's in the data. And so there's a book by Stephen Kuhn, and you've probably heard of it. The book is called Unsettled, and he goes through some good examples of language that's in the underlying scientific literature or the data sources, how that gets changed in the report itself. So there's a bit of bias in the filtering. And then there's even more bias in how the chapter summaries get written. And from there to what gets reported in the press is even more biased. So what might be a very benign message in the underlying science ends up in the papers as a much more alarmist message, but it's presented as if this is what the science is telling us.
Mm-hmm, mm-hmm. Okay, but what do you think drives such well, let's say such movement, climate movement? Is it some sort of ideology? Well, we talked about the political sides that are there, but still, maybe it's not only. Maybe it's money. You can make a lot of money if you set the conditions in a way that taxpayers are paying for renewables, for example. What are the reasons for this? Climate movement?
I would say there's a bunch of different movements that all found that they have shared interests here. Some of it is money, in the sense that there are just scam artists who if they see a big subsidy program being set up, they're going to go and try to cash in on it. And in order to cash in on it, you've got to help promote the climate alarm. So they're happy to do that. And they don't really care one way or the other. But if it means they have to print up a bunch of reports for people saying there's a climate catastrophe, so please buy our solar panels, and they'll do that. There are also people who are just allied to the size and expanse of government that they just want to. There's empire building, as we call it in economics. People who are connected to the government, they want to build their empires in the government. And climate is a great story for doing that, because it means every single aspect of life, you now need to have regulatory supervision and government oversight, and every single thing that people are doing, you can find a reason to have a giant bureaucratic staff running it. There is, on the apocalyptic side, like the Greta Thunberg kind of stuff, if you follow the finance literature, you'll notice that there are bulls and there are bears. There are people that, when they look at the direction of the stock market, there's some who are just always optimistic. It's bullish, it's always going to go up. But there are also some apocalyptic bears. They just think we're always on the edge of a catastrophe. Like, everything to them is a sign that the market crash is just around the corner. So there's a kind of an apocalyptic mindset. And people do that with environmental issues. So everything is a sign of the apocalypse. That the ecosystem is collapsing, the planet is dying, and they see it everywhere. And they get frustrated because other people don't see it. But if you look out your window and you think, well, it's actually a nice day out, and the air is clear, and the birds are singing, and everything looks just fine. And then the eco-apocalyptic types get really angry at that, because they think you're ignoring reality. You don't see this apocalypse. In the finance setting, the problem for bears or bulls, either way, is within a couple of weeks, you're going to be proven right or wrong. No one's going to listen to you unless you start making predictions, unless you put your money where your mouth is. That, okay, you're going to build a portfolio and see how it does. And if your portfolio by the end of the year has crashed and you lost all your money, then people know they don't need to listen to you next year. But on the climate side, there's no such reckoning. Like, this is such an abstract issue. If they predict that we're going to have terrible extreme weather, storms and floods and hurricanes and all the rest of it, well, I guess you're right, we will, but we always have. So then when a storm happens, they can say, see, told you. But we were going to have it anyway, because we always have. There's no real market test of these predictions, because no matter what happens, they can always say, yes, this is consistent with our theory of climate change. When a bad heat wave happens, you'll have these weather attribution people go in and say, yes, this is consistent with our models. Our models say that under climate change, we're going to have heat waves. Well, yeah, but we're going to have heat waves even without climate change, because we've always had them. And so this carries on year after year. The apocalyptic language never really runs into a serious test. I think there are places where we do test it. So some of the work I've done, especially with John Christie at the University of Alabama, is we now have long enough records of climate model reconstructions of the past. So from coinciding with the weather balloon record from 1958 onwards, or the weather satellite record from 1979 onwards, we can look at the layers of the atmosphere where climate models have said, okay, now we can observe the changes in greenhouse gases, we can observe the changes in the sun and in all the other components of the atmosphere. So we'll reconstruct, according to our model, what should have happened. And what we've shown is they always reconstruct far too much warming. There's a bit of warming in those records. There's a bit of warming in the weather balloon records. There's a bit of warming in the satellite records, but it's less than what all the models say there should have been. And so it's the models now just, they don't overlap reality. So in that case, we can say, you know, this has gone on long enough, and it's such a common pattern across all the models. At a certain point, we're entitled to say the models are wrong here. They've got too much sensitivity to greenhouse gases. Maybe there's another explanation, but the obvious one is they have too much warming in response to greenhouse gases. And we can even be more precise and say they have feedback processes that are too strong. So an interesting thing for your listeners is that if the CO2 in a climate model doesn't do a lot of warming, if you double the CO2 in a climate model, you'll eventually get about 1 degree of warming. But on its own, CO2 doesn't do much. What happens in a model is a little bit of warming from CO2 then triggers these secondary feedback effects that amplify the original warming. And this is where you have to say something about the behavior of water vapor, the behavior of clouds, the behavior of oceans and ice systems, and all these really difficult things to model, where over the oceans, you don't even have enough data to know what's going on presently, let alone understand the dynamics over 1,000 years. So the models are very speculative on those aspects. And they all generate large positive feedbacks, so that instead of having 1 degree of warming from CO2 doubling, you had to have 3, 4, 5, some cases even 6 degrees of warming. Well, there's enough time, like I say, enough time has elapsed. We can compare those models to the data, and there's too much warming in all of them. And again, it's not like some are too warm and some don't warm enough. They all warm too much. So I think that's a challenge that should be put to the modelers, and the modelers aren't really inclined to take it up or do anything. They never cull the models. They never take the models that are at the really warm end and say, okay, just forget it. There's no fixing this. You know, the Canadian model that warms 7 times too fast in the troposphere, like, why bother even fixing that? We don't need it. There's 40 models out there. Just get rid of it. And but they don't do that. They keep all the models up and running. And
Okay.
So getting, I guess, back to the point about the apocalyptic tendency of some people, what doesn't rein it in is there never seems to be that moment where you have to give us an accurate prediction and live or die by it.
Yeah, I mean, on the financial markets, like I said, instantly we'll get, well, people would not trust you anymore if you didn't, if you went bankrupt with your predictions and so on. It seems as if the message does not get through about the climate models in the same way, because they can still tell us that there is a lot of warming, and the media is taking it at face value and telling us that all the time. So I guess to sum up my question here is, how about this debate? You have said that in one of your op-eds I read that you shouldn't be afraid of discussing climate science, if I remember it correctly. But at the same time, as we know it, the discussion is, many times it is just shut down. It is said by fact checkers or whoever they are, by Wikipedia, that people like you I don't know what about you, but some other scientists in Wikipedia, it's the second sentence is that, oh, and he's talking about climate change, but actually spreading misinformation, and it's in the second sentence. So there's this kind of fight as well. So what about freedom of expression in climate science and academic freedom? Is there any?
It's yes and no. My experience has been when I've written papers that really challenge a certain aspect of the climate story. They're difficult to get published. There's no question. Journal editors will bend over backwards to find a reason not to publish it. They'll still go through the motions of having it reviewed, and if there's any negative comment from a reviewer, they're inclined to say, no, sorry, we're not going to publish it. Whereas if they like the conclusions, they would have said, okay, can you address these comments from the referee? So in the academic world, definitely there's a double standard in the sense that there's a lot of really crappy research that gets into top journals, the Nature and Science type journals, because it's alarmist, because the message of the paper is that with climate change, all the frogs are going to die or something like that. So yeah, we'll publish that, and because they know it'll get press, and they like the apocalyptic message. Whereas if you had a study that says, well, we've studied this carefully, and as a result of climate change, it's actually going to be good for the frogs, not bad for the frogs. Well, that'll get published, but it'll be some small ecological journal. It'll be, some out-of-the-way outlet that people just don't encounter. Going to the issue of the tone of the debate, for people in the general public, one thing I would say is you don't really have to feel obliged to argue it on your own. I think there are some really good sources out there. If for instance, if you want to discuss it with your family or your coworkers or things like that, if there's a topic that you're just interested in but you don't feel like you're an expert in, I would suggest some of the places to go would be, like a good one is Climate Discussion Nexus here in Canada. John Robson produces a lot of really good videos. And so there's one he did not long ago on heat waves. And I would say, okay, why don't you send that to your friends and say, what do you think? Like, have you seen this information before? Like, just put it out there in a neutral way. If you go out and say, you put a note on Facebook or anything like that and say, I think the claims around heat waves are nonsense, it's not really going to get anywhere because, yeah, people will just throw back at you all the standard lines. Well, you're not a scientist. The scientists all tell us X, Y, and Z. And so the discussion doesn't go anywhere. But if you give them some information that they haven't seen before, you can say, did you know this? What do you think? Why haven't we been told these things before? So find some good quality sources of information. I also mentioned Stephen Koonen's book, Unsettled. Some of the material in there, again, you can just say to people, did you know this? Like, I followed this issue for years. No one told me this. We should know this. People get used to the idea that Wikipedia is not balanced. I think there are some things where Wikipedia would be fine. If you want to, I don't know, look up something about why did World War I start? Well, Wikipedia is probably an okay source for that. But if you want to look up anything to do with the current political controversy, yeah, it's heavily filtered, and the editorial team are on the left progressive side. So you have to take that into account. And on the issue of freedom of speech, I think it's more effectiveness of reach. So people who question the consensus are it's harder for them to get a message out. Give you an example. Roger Pielke Jr., the American scientist, he's done a lot of work over the years on extreme weather. And he put out an op-ed a couple of years ago where he reviewed what the IPCC and all the experts had said about extreme weather. And in that summary, he pointed out that these groups don't say what people think they say. They're not calling climate change a problem of extreme weather. And then he did a talk where he said, when I pointed this out, I ended up getting hit hard by politicians. I was subject to a congressional investigation. I was shut down for saying this. So he wrote an op-ed. So then I wrote an op-ed where I reviewed his story. I said, this scientist exposed scientific information on climate change and got shut down for showing that it's not a crisis. And then a Canadian politician tweeted my op-ed. Well, then she got hit hard by activists. I mean, they really piled on her. They pummeled her quite. There's a lot of abuse. Anyway, she was basically bullied into retracting her tweet, issuing an apology, saying, I won't discuss this anymore. I'm not an expert. I looked at it and I thought, well, you've just proven the point, haven't you? I mean, the point of that op-ed was this whole discussion is heavily distorted, and you can't easily inject information into the public domain, even when it's absolutely solid scientific data accepted by all the experts. If it doesn't match the narrative, you'll get shut down. And she just proved the point yet again. So hopefully, at a certain point, people who follow this issue realize that, yes, there's a filter. If you're a passive consumer of information on this issue, you're getting one little cherry-picked side of the story. And if you want to learn more about it, you're going to have to do some work and find out a larger number of sources. And but they're out there. So it's unfortunate. But like I say, at the end of this whole process, you get to the policy decisions, and it's at the point where people are suddenly confronted with the cost of this madness. That's when all of a sudden the agenda on the alarmist side goes off a cliff, because people are not prepared to pay what they're being told to pay.
Yeah, hopefully this happens rather sooner than later. But Professor, our time is up for today, so it has been really nice talking to you, and a lot of new information for me and for my audience, and I think a lot to think about here. So thank you again for taking this time and talking to us.
My pleasure. Thanks for talking.
And of course, for our audience, if you would like to learn more about Professor McKitrick and his work, you should visit his webpage. It's rossmckitrick.com. And for our fresh content, as you know, we're at freedomresearch.org. So thank you, and see you soon.